Thank you.
Hello, mic check. Yes. Good afternoon, Bergen. How are we all doing? Are we still awake? I can't believe the weather yesterday and today. Oh my God. Sort of got speaking to a lot of speakers today and the organizers. Just want to give a huge kudos to the organizers. What an amazing event. I love coming here. I love Bergen. Super fun. But what do I love more? Perhaps talking about Kubernetes. I was joking earlier that there hasn't been an AI talk. Is that true? Maybe we should talk about AI. But perhaps not. We're here to talk about KRO, which is this Kubernetes Resource Orchestrator that has been open sourced by AWS. Typically, Harry. This is Harry, everyone. It's from Copenhagen. Hey. We talk about KRO, and to be honest, this deck is very much Harry's work. So it's been my pleasure and honor to sort of try to relay the message onwards. In other words, ask all the hard questions to Harry.
Yeah.
But let's not hold on. Why isn't this not working?
Just click once, and then you should be good.
I'm going to use your laptop.
Try to click it now.
Yeah, okay. How many AWS people does it take to fix a deck? Right. What I want to talk to you about is we see a change in pattern and how our customers build their centralized platform. For me, today, I want to talk a lot about DevX, and I would just sort of say, from the get-go, I want to sort of talk about KRO in terms of developer experience. I want to answer the why, and later on, we're going to talk about why KRO really deep dive. Our goal today is to go from level 100 to 400, because it's such a rare opportunity that Harry and I share a stage. So we hope to do you guys justice in that sense. But just circling back to what I said regarding centralizing platform, yes, it is a trend. We see a lot of it happening, and there's a strong reason for that. Just a show of hands, anyone works in a platform team here? All right, keep the hands up. Has anybody built their own custom controllers? Okay, a few hands went down. Good. I'm just curious as to what made you want to do that. Anyone want to shout out an answer? Perhaps it was fun? It's kind of fun. It is actually pretty nice. In our demo, there will be a custom controller that we cooked up.
Reconciliation loops are awesome. That's why.
Oh my God, Matt. Okay, so what I want to talk also about is the reason why we see a lot of customers building their own custom controllers and CRDs. What does the future entail? Can we do things better? In doing so, we will transition to Harry for some demo. But for those that's been to my talk last year in Native Day Bergen, you might see this slide. I really like this slide. I'm kind of a car person, and I often talk about platform as, do you want your platform team to be building nuts and bolts, proper engineering stuff, cogs and wheels, your team knowing everything about it? Or do you prefer sort of a nice put-together car that gets you from A to B? There's no surprises. Top leadership probably wants the car. I kind of like the nuts and bolts. But I guess in our day-to-day, we kind of need to meet somewhere in the middle, and we're slowly seeing more of this car way of thinking. And again, this is my other favorite slide, because in the time of need, and particularly, I ask a lot of questions, I get confused, there's a lot of stuff, you can't trust AI. But I know I can trust martinfowler.com, and also Martin Fowler himself, that this is a really solid quote, right? Like, this quote sort of embodies why we do platform engineering. It is not because it's fun, or it is, but it is an internal product. So what does that mean? It means that you should work with your end users. Ask them what problems that you can solve with your product immediately, and treat it like a product that you want to sell in the market. And I think that's really, really nice. And of course, no surprises, all of us here are probably super into Kubernetes. We love it, we love the flexibility. And we do also see that using Kubernetes to build your platform is the way forward, be it whatever cloud you're using. And that's really nice. We also see that the extensibility is supported by the operator pattern. For those that had their hands up, building your own controllers, outlining your CRDs. These are all part of Kubernetes by default. And it is ideal for building modern platform, be it for COTS or something a bit custom made. When you think about a platform in a context, we always work sort of backwards, as we say in Amazon, that we work from the ground up. You need to have good quality infrastructure and a control plane that works, that sits side by side with your worker nodes, where your teams are deploying their wonderful workloads. And then you sort of work your way up then to tool sets, tooling. For me, the biggest takeaway when I see this stack, it's about developer experience, a little bit overlapping with the platform team's responsibility. So for those that are familiar with the shared responsibility model, you can kind of see that there's overlap, that you, as a platform team, have kind of the product obligation to work with the application team in a way that it helps them through tooling, workflows, jobs, whatever. And Kubernetes is not without its complexities, right? Like just a show of hands that it took you years to feel comfortable using Kubernetes. Right? There's things I still don't know. Very often call Harry, he knows. Or when he doesn't know, we call somebody else. Like there's so much in this. And that's both good and also challenging. We see that, but when you apply this and you sort of tell your development team that you must know Customize or you must know Helm chart in order to work your cluster, to deploy your workloads, that kind of becomes a very, very steep learning curve. And perhaps they just want to deploy something once off and sort of kill that workload. They're really not interested in either AWS underlying infrastructure or how these bloody clusters should work. Understanding the resource relationship can also be tricky. We also see that managing this is not that easy. And often, I think, Harry, you coined this, YAML complexity, or you got it from somewhere else?
Yeah, I coined YAML engineer as well. Right?
Excellent. YAML engineering. And of course, from the platform team perspective, you will struggle if you allow too much flexibility to standardize, to simplify, to, for example, apply common security patterns to an ever-growing number of clusters. Right? If this is you, you don't need to put up your hand. I kind of know who you are, looking at you. But we all experience this. And at some point, I believe the story goes like this, that developers and scientists want a lot of flexibility. We want to try things, I myself included. Your platform team, your central team wants to standardize because they want to drive things forward. Let's not do things 20 times because there's 20 teams. Why can't we just do it one single way? At some point, you come and meet in the middle. Very often, we see that, oh, this is a whatever as a service. And then all of a sudden, somebody else has a whatever as a service. Your CRDs, a custom controller is born, and then kind of maybe one person is maintaining it. But that's the middle ground we see happening a lot. So then there's the notion of composability. Again, coming back to developer experience. From their point of view, how do they see their application workloads? What does it look like? Well, if I was a developer, I would choose my favorite programming language, or whatever that might be. I look upon my app and go, I need CI/CD. I need to deploy it somewhere. Okay. It needs to go in an infrastructure. Fine. In this case, Kubernetes. Great. If we're lucky, we get lots of users, it scales, right? Somehow scales horizontally, vertically, whatever, cluster order scaler or carpenter. Nice. I have data, information needs to persist, right? This is a no-brainer here. And I need to sort of provision this persistent storage somewhere called, as an example, called ACK. But what if, as we mentioned, the middle ground, what does that look like for a team? All of a sudden, you have this like strange third cousin in the corner, like, oh, hey, we're the CRD that this team has built. Why don't everybody use this? We have this wonderful controller. Whose responsibility is this? Like, why is this part of this picture? So I see that as a sort of a positive, a negative, I guess more negative outcome of Kubernetes being so flexible, so extensible, that your custom controller and the existence of it is the result. I would just sort of fast forward to a pretty bold statement, I think, and I agree with this, so correct me if I'm wrong, or challenge me if you disagree, is that we believe, Harry? Yep. Custom controllers that don't implement logic that differentiate itself is effectively technical debt. Please shoot us. So when we think about that, just circling back the sort of, I guess the boundaries of responsibility, your application team, again, interacts with your platform in a way that looks at names, images, resources, and databases. No surprises there. And that's pretty much sometimes, of course, the extent of how far they want to go. I was in the speaker lounge, I was in a pub yesterday and got talking to another speaker. He's the exact opposite. He wants to know what's underneath the hood. He wants to know how can I then help the platform team to come up with more templates, more golden path, more blueprints. Can I reconfigure the DynamoDB that is typically already default configured in some other ways? Can I extend the services? He wanted to know what's under the hood. And I believe that's also an interaction for developers that should be supported very well. So then, what do platform engineering team thinks about? Well, then it's your clusters, your DNS. Haha, DNS. Too soon?
Yeah.
Maybe how you deploy things on the cloud and with ACK, Istio, whatever you like for, as an example. Your consideration is vastly different from the development team. And of course, with your favorite, whatever cloud account team, you work with them or you don't to provision infrastructure. This, to me, is a very scalable blueprint, right? You can deploy the elements on the left very quickly and easily to all sorts of environments. Again, just to sort of highlight the strange cousin in the middle, CRDs and custom controllers all of a sudden becomes a responsibility between two groups. There's no single-threaded leader or owner of this, and God forbid, we need to make changes to it. Is there a better way? Yes, there is. KRO for Kubernetes Resource Orchestration, and during the demo, I have to speed up for you, Harry, that you will see that it might be the answer. And the question is, why isn't it already a part of Kubernetes? When you think about CRDs, if you have one controller and one CRD, yes, your world is very simple. You have a single blueprint. Easy. But then what if you have another blueprint that needs to extend another CRD or uses another CRD, and if you want to compose two of them together, all of a sudden you have CRD flavor AB or BC, or in the cases of these three, ABC. This is a little bit theoretical to think about, but it does mean that, as you're thinking about maintaining your controllers, how many different scenarios do I need to bake in code to support my application team? So hopefully with the demo that's coming really shortly, that you'll see KRO, it is open source. Feel free to use it. Google, Microsoft are all contributing. There's plenty of stars, 2.4, sorry, and 45 contributors. And this is a way to standardize, resource orchestration. Platform building of KRO, in my opinion, has never been easier. It makes authoring, and this is, again, without seeing the demo, it's hard to imagine. How does it make authoring that much easier? Well, hopefully we'll dispel that in a second. The composability supported by KRO is what makes it special. So it can go in a cluster where you have your existing custom controller, and it can extend and be composed off it. So you can easily extend the next, let's say, whatever is a server's version 2, but done with KRO. In my opinion, it does replace CRD authoring in many ways with simple schema, and the schema and the power of this to create instances of these application stack is through resource graph definition, which you'll see in a bit. So then, what will be my developer experience? Well, just like before, I care about if I have a private endpoint, what database I need to provision, and I can pull this out of kubectl explain, in this case, a custom resource graph. It's pretty nice. I know what I have to configure, and Bob's your uncle, you're off running. So then, ultimately, I think this is a good fit, but don't take my word for it. Let's see it in action. we've dragged Harry all the way from Copenhagen in his sunny cabin to talk about potentially starting a startup managing cabins.
Yves told me you guys love cabins here, right? I don't know, as a Danish person, I'm not used to it. We just have something like a colony here, and that gives this full-on steroids kind of a living in the woods kind of a thing, right? So I'm going to use cabin as basically my reference for the demo. Let me just quickly mirror.
Does everyone have a cabin like this? Yes.
See, yeah, it looks good, right? All right, I'm saying this right. It's hytte, right? It's hytte. Good. I just noticed some of you mentioned that you have experience doing CRDs, etc. But I'll just take a little bit backwards and start from the beginning. So if you get a fresh installation of Kubernetes and then just say, Kube, give me those API resources that you have, or basically the different kinds you have in Kubernetes, what you're going to see is some of the obvious ones. The parts, the deployments, jobs, etc. that you normally see. That means Kubernetes has types or objects that you can actually work with, massage it, manipulate it, etc. to bring out your business context, right? So what I can do is I can say, Kube, give me all of those parts is a kind here, and give me all of that within the namespace kube system, namespace, aka folder, right? Great. Now that I know I can interact with kinds, I can actually say, Kube, increase the number of deployments for this particular namespace. I can just, in my case, I've just said, I have a type called coordinates. It's a deployment, just scale it up. I can query and I can check how many there are. Right, scale up. And I can scale down. And then I can really interact with it with the defaults that's there in Kubernetes. What I really like Kubernetes is they really did not try to boil the ocean. They basically gave you the basic and then said, go figure it out. You get the power of extensibility. Go do whatever you want to meet your business needs, right? And that's the core of pretty much any CNCF project that you see here. Without those extensibility, none of this ecosystem would happen. So he said, Hytte, let's go build a Hytte platform, right? So let's start defining our own resources. Let's define my type is basically Hytte, and I'm in the business of creating a chain of Hyttes across Norway. Right? Dozens of cabins in different locations. It could be in the mountains, it could be in fjords across Norway. Guests can directly book and have an Airbnb or something else as integrations. And the question is, can Kubernetes manage this? Yes, if you can actually build and order pizzas over Kubernetes, Hytte is no big deal. Right? How do you do that? Right? I go and build that custom resource definition. Right? I define a type for Hytte. In my case, I basically define the Hytte here, where I'm saying, well, the composition of Hytte is that I need to know where this particular cabin resides, the location, what are the amenities, the capacity, the season type that it offers. Maybe it's a winter type, it's a summer type, it has a sauna, or maybe not. And then for those admin operators, I need some overrides on top of that, right? Something to disable the bookings. Yes, something about weather closures. If there's a lot of snow, just close it down, et cetera, et cetera. As you can see, I'm able to put in my business logic into this CRD, right? And when I apply it, I have a type now called Hytte. Right? Once I have that, I can create instances of this. Here, I am trying to create an instance of a Hytte with amenities defined here. The location is fill, capacity is mentioned, the season is year-round. I can do those kind of things. I can create an instance of this. Right? I can verify that. Do you exist? Yes. I can create another instance in the fjord with slightly different variations. So how would this relate? I mean, in the platform reference, you would have created a CRD. Maybe it's a WordPress site. You would create a definition for your WordPress site. People can create different variations of that WordPress site and have that available for them. Self-service being fueled here. This is the most powerful thing when you're doing CRD for me. I'm not asking give me pods. I'm not saying give me deployments. I'm saying give me all the Hütte within Kubernetes, right? I'm not saying things that I've composed down into primitives such as pods and deployments. I'm clearly saying give me all those WordPress sites within Kubernetes. What this basically means, I've extended the Kubernetes API to speak my business language.
But Harry, this is interesting. Isn't this just like a glorified key value store at this point?
Damn you, man. So all I've done so far is shown you a really expensive key value store. Nothing else is there. What really makes the difference is the controller and the operators, right? So you have the controller that basically watches the resource as it's created and is changed. Every time there's a change, it says there's something changed within this particular instance of the CRD. And then you get Kubernetes reconciliation that is constantly trying to achieve that state. And the business logic comes in the operator, which includes all those domain rules, basically takes what's in the definition of that particular instance of the CRD and actually does something about it. Right? So, for example, maintenance, weather aware. If the weather's aware, really go into the booking system, shut down the Airbnb bookings. It does all of those kind of things. That's where the operator comes in, right? This is where the smart stuff happens. This is basically something, a controller that is actually watching if something has changed. So this is simple when you're just working with a single operator with a very simple kind of kinds. But the more you're trying to build on top of it, and this is what I noticed with some of my customers who are running not just tens, they're running hundreds, if not thousands of applications across not just 10, 15 EC2 instances in the Kubernetes. I'm talking literally EC2s in the thousands on the Kubernetes, right? This is a scalability problem for them, mostly because as the CRDs grows, as Yves mentioned in his Venn diagram, when you just have two, you already have, you might need to account for 3 operators, right? As the number grows, the number of bespoke operators you need to build to take care of all those requirements. Of course, I'm working on the assumption that there's a 1:1 relation between a CRD and an operator. Then it's an exponential number, right? And this is basically what KRO is trying to do here. KRO is simply trying to build an abstraction layer that helps in simplifying the abstraction. Okay, jargon. KRO is a really nice YAML massager. It massages from one state to another state, right? I hope that makes it simple, right? It's just a YAML massager. But you might ask, shouldn't Kubernetes be already doing this? Do you need yet another tool to do this? I don't think so. You need yet another CNCF to do this. And that's basically where our intentions to build KRO came from. If Kubernetes can do a lot of things, build operators, build extensibility and everything like that, it should be able to do a little bit of YAML massaging out of the box. Deploy Kubernetes, your kubectl should be able to do that. And that's basically the origin of KRO. And we've started with KRO hoping that it would stay out of the Kubernetes ecosystem, but we've donated it to Kubernetes. So KRO is actually a part of Kubernetes special interest group. If we do our job well, maybe we can just kill KRO and just becomes Kubernetes. That's the pitch, right? So what does KRO do? You're not going to get out of YAMLs. You need to do more YAMLs. Right? So what KRO offers in its core is basically what we call resource graph definition. It's yet another different kind of a kind. And it's basically open API specs. You can actually define the API, the kind that you're trying to build. You can define the specs, the type. The location is a string for me. The enable sauna is a Boolean, or it's a Boolean with false or true. And then I can have statuses that I want to respond with. What is a status field? So I have an operator that acts on the CRD and then comes back and said whether whether the heater is ready or whether the sauna is good to go, etc. So you can act and report those kind of things. You have additional print columns, so you kind of get the pretty definition when you try to get those objects that you've resulted based on creating this resource graph definition. The important bit is the resources, right? This is the important bit. So what CRO underneath does is to give you the ability to do a composition across anything. It can be internal CRDs that you have defined, or it could be CRDs that are for AWS and S3 bucket and RDS, or it could be something that's a little bit more naughty, where it could be a CRD that is meant for Crossplane or something in Google. So you can actually define the basically the composition of your application or the business needs or the application stack, basically. It doesn't limit you, because CRO is not really implementing any of the business logic. It's just massaging the YAML. So all it's saying is, I'll build you those composition and give you the end state CRDs, as long as your end state CRDs are backed by actual operators that can do something about it. Right? I'll show you what that means. Just before I go there, just want to let you know that it comes with cell. This is kind of splitting hairs to have YAML and cell expressions within the same thing. But we made a choice. Let us know if this is a good thing or a bad thing. Right? The ability to actually have things such as value injection, conditional statements, expressions, examples I've just shared here is some examples like include when, etc. are great resources to actually build the composition depending on something else in your YAML. Okay. Have you worked on Helm? If some of you worked on Helm? Have you ever tried to see into Helm and see how Helm actually renders things in sequence? Like first it renders the secrets, and then it renders config maps, and it then renders deployments, etc., etc. There's a sequence of dance that it does. Have you tried to see how that works? Yeah. So effectively, it is basically convention-based that you actually have within your templating things, so you can actually set the order. So basically, that's how Helm is actually doing. It's basically based on a convention that is set, then commonly agreed. What we do differently in CRO, we actually build, help me here.
A DAG.
A DAG.
Stands for Directed. Thank you.
Thank you, Philip. So we build a DAG, so we actually know the sequence of the dependencies to be able to deliver the application stack that you're looking for, right? So we actually, based on the YAML, we build a DAG. So this guarantees us during compile time to say whether we'll be able to deliver your application stack as you represent or not. Great. Let's try CRO. Right? How do you install CRO? Right? That's how you install CRO. Helm. Right? So I've just done that. I've just tried to install Helm. So Helm is here to stay. By no means this is trying to move or push Helm over. Neither it's trying to push anybody over CRO. It has its life of its own and is trying to do its own things. For now, it's something we're trying, and if there's enough interest in it, it'll survive. Otherwise, it'll just die out. So I have built the Hütte platform RTD, which is a composition of the Hütte itself, the sauna booking system, the cleaning partner booking system, and the really nice firewood service. Right? This is my composition of what I call a Hütte platform. Let's just deploy that. kubectl apply, create it, just to be sure. It gets created. OK. That's not nice. It says inactive. That means this is not working as expected. Let's look into why it's not working. Let's just try to describe that. OK, some info here, message. It failed because it's not able to resolve a kind called sauna booking. The reason it failed is because it could not see me create a sauna CRD ahead of time. It created the DAG and then thought that, smart person, you don't have a sauna in the system, so create that first. Right? And when I tried to really explain it, just to be sure, oh, why am I not having the white? Yeah. If you look into the topological order, it prints out empty because it's not able to really compose a proper DAG. Now that I go and create those backing CRDs, in here I'm creating the Hütte, of course, the saunas, the cleaning partner, and the firewood service. So I'm creating all the necessary backing service. And I'm going to verify they're all created. So let's go back to the place where I've defined where I tried to describe the Hütte platform, and then try to, oh, I need to give a little bit of time for the reconciliation. This happened before. No. Sauna booking.
We should have sacrificed a rabbit earlier this morning, but
Yeah.
my bad. Too soon.
Okay.
Will restarting the controller pod force the reconcile again?
Yeah, that's basically what I'm trying to do. Hold on a bit. How much time do I have? 6 minutes. Gonna try to recover. Let's see if I can actually. Okay. There you go. It took some time to reconcile.
Yay!
We are AWS, we know our stuff. Except for when it fails.
Exactly.
Right, great. So what you can see here is that my RGD is ready and is good to consume. Right, I've built a composition of a Hütte platform that includes a Hütte itself, a firewood service, and Airbnb integration. I've done all of that. And you can see that that's good to go. When I actually try to print out the entire definition, it actually gives me the topological order. You can see the first thing, to have a Hütte platform, you need to have a Hütte. And then something else, and then something else. Right? Great. I'm going to just deploy a quick cheesy peasy controller. The controller is really the case where it has some actual business logic. I'm just going to simulate something to get some kudos here. Again, everything is slow, man. Yeah, I just have a controller running, and the point of this controller is that it does something on top of my CRDs, etc., that I actually define. Next, what I've done here is I've tried to create an instance of my Hütte platform. I'm trying to say that I'm not trying to create a Hütte, a firewood service, and all those things. I'm just saying I want a platform, not individual nuts and bolts, but actually saying I need the entire car engine. Back to your reference. So saying the location is your enable the sonar, true. Cleaning partners, I define the cleaning partners. The season is year-round. That's all what your developer would use, the API that they would use in order to create a stack set to get to what they plan to work on. If I actually try to verify this, you can see here, I see the instance of failed cabin and location is failed, sonar failed, and the rest of the things failed. And that is by intention because my Python operator is not functioning as expected. So I get to see if my operator did something or not, right? So imagine that there was an operator that was backing my sonar service, and if it didn't do the job and update the status, this is what you would see. Whereas my Hütte, it actually went and created the Hütte instance, and that's why you see the true. I mean, this is basically me defining what I need to return in my YAML spec. It could be your business logic in your application. So let's look at what KRO has created for me. The ones that you would notice are the ones that are automatically created at 97 seconds ago. So what KRO did is it took my resource graph definition and massaged and basically created these three CRDs that I need in order to create the Hütte platform. The massage part, right? It took the big one, split it up, figured out it needs to create these CRDs, and create those CRDs. And each of these CRDs are backed by a microcontroller within the KRO, to be honest. So now, last 2 minutes, I can go in and I can actually ask, give me the definition of Hütte platform, and this is what I would see. The Hütte platform is state as active, it's created. The topological order is this basically what I defined with. And you would see the composition as I set it out to be. So this is how KRO is actually working and powering some of the platform building efforts with some of my customers, because they just want a simple composition application to be able to take a large YAML and create a massage or basically massage version of those YAMLs. It's as simple as that because they really don't want to build the variations that are backed by each individual operator for that CRD. KRO is still, it's not a, it's not version 1 yet. It's still an experiment that is fastly heading towards some sort of maturity that we ourselves within AWS are planning to use. The ambition with KRO is high, which is to contribute back to Kubernetes and make Kubernetes be better at abstractions. And that's where we're at.
Brilliant. Let's go start the Hütte business. Thank you, everyone.
Any questions? Bring the tough ones. Yeah.
So, for example, I don't want to create a firewood before the sauna is ready.
Yeah.
So then my sauna operator, as a state, is ready.
Yeah.
Can I then get the firewood to only be created?
Yeah. So that's basically in the cell expression. You can actually define those kind of depends on kind of relation. Think of this as more like a Terraform way of doing, like when something is created, then create something else, and you branch out depending on what is the result of something that happened in the beginning. So yes, you can do those kind of things. I haven't tested myself.